In this session, we're going to talk about data population analysis and visualization over the SustainGraph, a knowledge graph developed in the scope of European Union's ARSINOE project. We are a team of 5 people working on the SustainGraph, and we all come from the Network Management and Optimal Design Laboratory in the National Technical University of Athens. So the SustainGraph is a knowledge graph that aims to track the progress towards the achievement of United Nations Sustainable Development Goals in national, regional, and local level. It hosts a huge amount of data, and it aims to act as a unified source of knowledge around information related to the Sustainable Development Goals. It thematically aligns all this data coming from different sources in order to facilitate analysis that may come from scientists from different disciplines. This is an overview of the SustainGraph. All of the information are related to the Sustainable Development Goals, and starting from indicators that are set by the United Nations, but also from the European Union, and they are semantically aligned between them. In the SustainGraph, we also host indicators coming from third-party sources in order to enable analysis performed by the case studies of the ARSINOE project, where each case study focuses on a different geo area around Europe. There are also a lot of information about hazards and associated innovations that could be adapted by the case studies in each area. On the other hand, we also host text documents and policy documents related to the Sustainable Development Goals that may come either from the European Green Deal, the country-specific recommendations, or national determined contributions. And in this link, you can find more about the SustainGraph, and also I provide the GitLab link where you can find all the pipelines that we introduced the data. So in order to be able to introduce all these text documents to the SustainGraph and map them to the Sustainable Development Goals, we created an open source Python library called the SDG-detector. So this library aims to classify text, and in our case, policy documents, with the Sustainable Development Goals. And again, I provide here the link so you can find more about it. This library combines 2 methods to classify text. The first one is a classification method problem by using a transformer-based model, which is pre-trained but fine-tuned. And the next method that we use is a keyword detection, where we find similarities between keywords from text documents and the keywords of the Sustainable Development Goals. So by combining these 2 methods, we come up with an index called the SDG index, which maps each text document to every one of the Sustainable Development Goals with its own weight. Now, in order to make all this data accessible to the end user, and the user that doesn't have a technical background or doesn't know how to write cipher queries, we try to incorporate natural language queries transformed into cipher queries by using large language models. So in order to do so, we tried, apart from the GPT 3.5 model from OpenAI, some open source models, such as the Code Llama with 7 billion parameters and 13 billion parameters, and also the Mistral model with 7 billion parameters. And all of them are instruct-tuned, they're instruct-tuned version. Here you can find more information about this model in order to compare them. They are all recently released, and their performance is comparable in most of the tasks. So in order to test these models on cipher queries, over the SustainGraph, we used prompt engineering in order to refine the input of the model. And with each prompt, we give to the model instructions of how to write cipher queries based on some examples, but also the schema of the SustainGraph. Also, in order to control the output of the model and the randomness, we used the Transformers Hugging Face library in order to customize some of the parameters of the model to make it less creative and come up with a more deterministic output. So all of the models with some different temperatures are tested on 14 basic questions over the SustainGraph. And in this table, we can see how they did if they answered with the right cipher query in the question, and most of them did pretty well. However, what we also want is for the output to be in the expected format, meaning that we just need the cipher query and no extra explanation that many of them provided. So as an overview, some of the models gave wrong directions in the relationships, or they gave some wrong properties and relationships that didn't exist in our schema. And as we can see in the example here, many gave outputs that was not in the required format, meaning that they generated some extra text with explanation for the query that they created. However, we have to keep in mind that the SustainGraph has a very complex schema, and we haven't provided yet to the model data types of the properties. And also the syntax in the user's question is very important and determines the output of the model. And in our next steps, we want to fine-tune one of these open source models on the SustainGraph and see the results. We also wanted, apart from the natural language queries, to make all this data accessible to the end user with user-friendly visualizations for someone to be able to explore the SustainGraph and see complex relationships that it hosts in an illustrative manner. And in order to be able to promote this understanding and support decision-making, we have created a visualization kit. To create this visualization kit, we used these technologies, a Flask Python server and Quasar and Vue JavaScript. So a user can explore the sustainable development goals with the indicators and series that they are related with. It can see they can see useful graphs, for example, mapping of the European Green Deal strategies with the Sustainable Development Goals. And from this graph, we can see that the strongest connections from all the strategies go with the goal 7 and the goal 13, which means that they focus more on clean energy and climate action. However, less focus has been given on gender equality and inequality issues. Another indicative example is from the visualization kit. Someone can see the mapping of the country-specific recommendations of each country per year with the Sustainable Development Goals. And here we provide an example of Greece in the year 2020, where the focus was given more on goals 8, 9, and 3 in economic growth and industry. However, in 2022, we can see a shift towards clean energy. And finally, someone can go through climate-related hazards and explore a list of innovations with their maturity level that are related to these hazards. And these innovations are provided by the Climate Innovation window. So thank you very much. I'm happy to answer any of your questions. And if I have time, I can go through the visualization kit for a demo. I'm not sure. Okay, I have a couple of minutes. So this is the visualization kit that we have developed, and someone can click any of these tabs and explore the goals with their indicators and their targets per goal. There are also some very useful graphs, as I presented, where you can see information about how these text documents and policy documents are related to the Sustainable Development Goals. And the same for the country-specific recommendations. We can see some useful diagrams over time. And we can select the country that we want to display and for the year that we want to display. And finally, just a quick overview of an analysis that we have performed by using indicators coming from the SustainGraph about the vulnerability index in Europe across the years. And with this plot, a user can see how the vulnerability evolves in all the countries around Europe. So maybe I should stop sharing and give some time for any questions. And the whole team will be happy to answer any questions. Okay. What is the biggest challenge in working with the Sustainable Development Goals data? So does anyone from the team want to give some input here? Because there are a lot of challenges that we have faced.
Okay, I can say a few words, but my sound is good because of a little noisy here. I think the biggest challenge that we have faced has to do with the data quality, because we have got access to numerous sources of data, especially time series data and special data. However, data quality is not always good, so we have to put a lot of effort to make data quality assurance processes and be able to properly select the data that have to be introduced in the graph so as to give them to scientists for qualitative analysis. I think this is one of the main challenges. And the second thing is semantic alignment of indicators and concepts coming from diverse data sets. It's also important to be done to reduce this overhead from the scientists. Just a first, a very quick response, let's say, on my side, but Elena and Joanna may also complement.
I also agree with Tassos in both comments that he made. I would also like to add that a big challenge for our research team is that even though we have managed all these years that we work on this to get a very big pool of data that is semantically aligned and so on and so forth. The big challenge that we face right now is to offer this all this richness to the end user. So all the efforts that we do via the visualization kit and the fine-tuning of open source LLMs is exactly because we want the SustainGraph not to be a theoretical work of high interest only for the researchers, but only to be useful to the end users, to the data scientists, and to any person that wants to explore the available data there.
Great. I think our time is out. So thank you all for joining this session, and enjoy the rest of Note.
Thank you very much. Bye bye.
Thank you very much.
Bye.